Welcome back. In this last video, I'm going to go through a couple of more examples of these graph transformations. They're a little bit funky the first couple of times you do one, but just go through a sort of logically look at the original parent function, look to see what's happening to the transform function, and then get an idea of how the old one and the new one are related, and try to match up some points. So this is the cosine function. What's happening to it is going to be shifted to the right pi over 2. So it's going to be shifted right pi over 2. And then up 2. So this isn't terribly bad, right? The original cosine function looks like this. It starts at 0, 1, and it goes up to 2 pi. So if I shift it to the right pi over 2, then instead of it starting here, it's going to start here, right? And that means that instead of it ending at 2 pi, it's going to end at 2 pi plus a little bit more. So shifting it to the right pi over 2 means then it's going to hit its bottom at 3 pi over 2, and then it's going to come up back here, and the other part's going to run off the graph. So here I can do a little bit more on the other side. Right, I can move it across there, so it'll cross here, and it'll hit a bottom over here. So this is what the graph would look like without the plus 2. Right, so there's the graph shifted pi over 2 to the right. Oh my goodness, it looks very much like a sine curve to me. That's what it is. All right, now take the whole thing and shift it up 2 units. So take that whole thing and shift it up 2 units. And so everything that was 0 becomes a 2. Things that were 1s become 3s, 2s, goes down in 1, back up here. Right, we can do the same thing on the other side also. Like so. So there's my graph for the cosine function. All right, let's try the next one. Let's take a look at this one. 2 times the sine of x plus pi. So this one's going to have an amplitude change. The new amplitude is going to be 2, so it's going to be taller and go down lower than the other ones. And the only other thing that happens is a phase shift. So it shifts itself pi to the left. Although, really, if the period's 2 pi, shifting it pi to the left and shifting it pi to the right are the same thing. Right? So normally, what does a sine curve do? Normally, it starts at 0, 0. It goes up, down, and back up again. So with an amplitude of 2, now it's going to go from -2 to 2 instead of from -1 to 1. Shifting it pi units to the left means now it's going to start here. It's going to go up, down, and back up again. Which way? Well, it's going to start over here, and except instead of going up to just 1, it's going to go up to 2. So halfway in between, it's going to go up to 2. Halfway in between here, it's going to go down to -2. Halfway in between here, it's going to go up to 2, and so forth. So let's draw this and see what it looks like. I know, this is fascinating watching me draw this on a tablet, isn't it? There it is. Okay. You could have almost convinced me that, well, actually you could convince me, that this also looks like the sine function flipped upside down, right? Doesn't it look like just the plain old sine function that used to come up and back down like that, just flipped upside down, like so, right? Interesting things happen when you have periodic functions like this and you shift them fractions of their period. That's what happens. So this is what the function looks like. 2 times the sine of x plus pi. Ooh, this is something different. This is the tangent function. Tan of x minus pi over 2 plus 1. So remember, the tangent function is the one that has all those vertical asymptotes. At negative pi over 2, there's 0. Here's positive pi over 2, and so forth, and the graph comes down like this. So instead of doing that, it's going to move to the right pi over 2. So instead of having those vertical asymptotes at negative pi over 2 and pi over 2, now you're going to shift it to the right, and you're going to get those vertical asymptotes at 0 and at pi, and at 2 pi. And then the other thing that's going to happen is everything's going to shift up 1. So instead of the graph going through the x-axis at pi over 2, it's going to go through 1. It's going to go through 1 over here. And so without plotting individual points, I'm comfortable in saying it looks like that. All right, so the tangent function shifted pi over 2 to the right, and then up 1. And then, of course, it continues over here, too. We could do another branch over here if you want. All right, so there's my tangent function. So for each of these, the first thing you do is you look at the parent function. Does it look like a sine, a cosine, a tangent? See which way it moves left and right. Check the period. Check the vertical shifts. All right, last one here. Application problem. Figure shows the depth of water on a boat dock varies with the tide. So high tide, the boat is further up because the dock is filled with water. On low tide, it dips down. So it's never less than 5 feet. Notice the depth of the water is never less than 5 feet. And it's never more than 13 feet. Middle is 9 feet. So on a certain day, low tide occurs at 4 a.m., high tide at 10 a.m. So 4 a.m. is 4 hours after midnight. That's right here. 10 a.m. is 10 hours after midnight. So you notice in the problem, that's high tide. Low tide here, 16 hours after midnight, which is 4 in the afternoon. And then 22 hours after midnight is 10 at night. And so I took this from the textbook. You'll notice that the piece in the middle here that's blue, that's one complete cycle. So it starts here halfway between 4 and 7, 4 and 10, so it starts at 7. And it ends halfway between 16 and 22, which is 19. So the first thing is they asked me to use sine, which makes sense because, remember, sine is the function that starts here, goes up, down, and back up again. And doesn't that look like what this blue function is doing? It's going up, it's going down, it's going back up again. So this is plain old y equals sine x. And then I have a couple of things to consider. One is, look at the amplitude. From this center line here at 9 feet, it goes up 4 feet this way, and it goes down 4 feet that way. So the amplitude is 4. We also said that that center line is not the origin anymore. Now it's plus 9. So it's a vertical shift of 9. The only thing now I got to be concerned, well, I have to be concerned about two other things. One is that this thing doesn't start at 0, right? Normally the sine function starts at 0, 0. But this doesn't. It starts 7 units to the right. So how do I say 7 units to the right is the opposite, so it's x minus 7. And then there's one more thing to take into account here, and that is that the period isn't from 0 to 2 pi. It goes from 7 to 19. Ooh, well, that's interesting. This is one of those cases where it's kind of nice to have that formula that says the period is 2 pi over b. Well, what's the period here? It starts at 7, it ends at 19. 19 minus 7, oh, it's 12. 12 hours. So 12 hours equals 2 pi over b. So let's multiply both sides by b. I get 12b equals 2 pi. Those b's go away. Divide both sides by 12. And 2 pi over 12 simplifies to pi over 6. So what is the equation that we're going to write in final form here? Well, there's two ways to write it. I might write it like this. Y equals 4 times the sine. I'm going to put that pi over 6 on the outside. X minus 7 plus 9. But the question said to write it in this form, a sine bx minus c. So all that means is distribute the pi over 6. So if you're doing this on a test or something, I would certainly take that first line as a correct answer because that's probably how I would leave it too. But if you're doing this on the online MyLabs homework, they might want you to specifically write it in that form. So y equals 4 sine, and then go ahead and distribute that pi over 6. So pi over 6 times x, 7 times pi over 6. Then add your 9. All right, so if you graph it that way, actually if you graph it either way, you're going to get the same thing. I did it the first way because then I could see right away that that b value is pi over 6, and if I had to go back the other way and graph it, it's easier for me to do that. If the question specifically wants it in a certain form, like this one wanted it in that form with the bx minus c, then we follow along and distribute that pi over 6, and we're done. You could always go on to Desmos and graph them both, set the window up to look like the window in this picture, and you'll see that they're both the same graph. All right, and that's it.